Okay, 6.6, last lesson of the chapter here, and it's going to be about comparing measures in triangles. So it says, imagine a gate between fence post A and B that has hinges at A and swings open at B. As the gate swings open, you can think of triangle ABC with side segment AC formed by the gate itself, side segment AB representing the distance between the fence posts, and side BC representing the opening between post B and the outer edge of the gate. So notice that as the gate opens wider, both the measure of angle A and the distance BC increase. This suggests the hinge theorem. Okay, so we have 612 here is the hinge theorem, and it says that if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the other angle, then the third side of the first triangle is larger than the other. Okay, so if I'm looking at that in terms of these pictures over here, we know that WX is greater than ST since the measure of angle V is greater than the measure of angle R. Okay, so then we have the converse, which is very similar, but kind of remember goes in the opposite direction. So if two sides of a triangle are congruent to two sides of another triangle, and the third side of the first triangle is longer than the other side, then the included angle on the first is larger than the other angle. Okay, so again, looking here at this picture, we know then that the measure of angle C is greater than the measure of angle F, since the length AB is greater than D. Okay, notice I don't put the segment sign again because I'm referring to the length. Okay, so example 1 here, given that segment ST is congruent to segment PR, how does the measure of angle PST compare to the measure of angle PSR? So I know that PT is greater than RS because I know that 24 is greater than 23. So that's how I figured that out. So then I know then that the measure across from PT is the measure of angle PST is greater than the measure of angle SPR. Okay. Right. Turn the page then. Okay, given that segment JK is congruent to segment LK, how does JM compare? I guess, actually, let me come back here for just a moment. The reason that I can say all of this is because, so I guess I should say first, and then this is all second. The reason why I can say this is because we have this segment is congruent, and we know that segment PS is congruent to segment SP by reflexive. Okay, then I can go on to say this, okay, because it has to have two sides congruent first, okay? Sorry, I kind of missed that part. Okay, so then, like I said in example 2, we are given that segment JK is congruent to segment LK. How does JM compare? That should say 2LM. Okay, so here's my one side. So I'm going to label it the same way. I know that KM is congruent to KM. Okay, again by reflexive. Okay, so then because of that, I can say that the measure of angle JKM is greater than the measure of angle LKM. So that means that JM is greater than ML. Okay, so that's all that we need there. All right, last one here is looking at a real life problem. Okay, so 2 groups of bikers leave the same camp heading in opposite directions. Each group travels 2 miles, then changes direction and travels 1.2 miles. Group A starts due east and then turns 45 degrees north. Group B starts due west and then turns 30 degrees towards the south. Which group is farther from camp? Explain your reasoning. Okay, so what we have here is that we have 2 groups. One's going to start and go due east. So if I'm thinking like map, right? Here's my little compass. North, south, east, west. Okay, that's what we're using in terms of this problem. So if I'm going due east, that is group A. Okay, so I started due east. That was 2 miles here. Okay, then changes directions and travels 1.2 miles, and that is a 45-degree turn north, okay? So we're going to pretend as if this line continues, and we're going to turn towards the north, so that means we're going to go up, and the line needs to make a 45-degree angle here, okay? And so then that's a 45-degree turn, okay? Because it's as if I was going straight and then I'm turning north 45 degrees. So that one is 1.2 miles. This does not have to be drawn to scale, okay? Just as long as everything is labeled correctly. And then we're going to figure out how far away they are from camp. So that would be this distance here, okay? So then that is group A. So then I want to figure out what group B is doing. So group B takes off due west 2 miles, and they turn 30 degrees towards the south. Okay, again, I'm going to pretend as if this is still going to go straight, and then I turn 30 degrees south. So that would look like this, because this is the angle that's 30 degrees, and then they traveled 1.2 miles there. Okay, so we are trying to figure out who is closer to camp, A or B. So honestly, I'm wanting to know, we'll call this one X and this one Y. I want to know which one is smaller, okay, using what we've done today. So from what we know in the past, we know that a straight line makes 180 degrees. So that means that this angle here is 150. And we know that this angle over here is 135. So I know then that 150 is greater than 135. So that means that group B, or Y, is longer, right? Is farther. I'm going to put longer below it because that's in terms of Y. Is longer, or group B is farther from camp than group A. which I know is X, and that is shorter. Okay, I'll just write shorter underneath here. Okay, so group B is farther from camp. Is your final answer there. Okay, and that uses the hinge theorem to explain. Okay, all right, that should be all that you need. Let me know if you have any questions.